We are back, and this time let's have a look at starting to put our kind of structure of our convolutional neural network together. So in the source file, let's create a new package, and I'm going to call this layers, so everything to do with our layers are going to go in here. Now what I did for this build is I created an abstract class called layer, and that allows, and for all the layers that inherit from that allows them to interact without knowing what layer's next. So that means that you can create a really modular convolutional neural network. You might want no max pool layers, you might want several convolution layers in a row, you might even want a fully connected layer in between. So the idea of this class, this abstract layer class, is just to like kind of glue all those layers together and ensure that we've kind of defined all of the methods that we need for each layer. And what do we want in this abstract class? Well, we want to keep track of who the previous layer is and who the next layer is. And this is good for forward propagation and back propagation, so just knowing that we always have that there. Now obviously our last layer is not going to have a next layer, and our first layer is not going to have a previous layer. But the layers in between will, and we can do some checks to check, hey, am I the last layer or am I the first layer? So now for all of our layers we're going to do something called getOutput, and what getOutput is going to do is it's going to do all the calculations required in this layer and then pass our output from our calculations down to the layer after, and so on and so on and so on and so on until we reach the end of that chain of layers, and then the last layer will do a check, hey, I'm the last layer, I'm going to return the result I got, and that will come back up the chain, back up the stack, I guess, our call stack, back to the first layer, because the first layer is the layer that called it. So I'll show you what I mean. Well, public abstract double get output. And that will take a list of matrices or a list of two-dimensional double arrays as input. And we get this double back. So this final double that we get back out of the getOutput method, that's going to be basically our network's best guess. So hopefully if we give it the number 7, for example, we're going to hope that its guess comes out 0, 0, 0, 0, 0, except for the 7th number will be 1, 100% confidence that our number is a 7. At least that's the goal. And as far as input goes, so here, for example, for a convolutional neural network has layers of different types that want different inputs. So the fully connected layer, which is the most simple and probably the one that you might be most familiar with, just takes a vector input. However, our convolution layer and max pool layers take matrix inputs, in fact lists of matrix inputs. So that's what this is. But we're going to do something called polymorphism, and so for this method we want to be able to call it with either a vector or our matrix list. And that's so that when one layer goes to call the next, hey, can I get your output, we don't need to worry about converting data between these two layers. I hope that kind of makes sense. Anyway. And then similarly, we're going to have some backpropagation. So, this doesn't return anything, it just updates all the weights of that layer and every layer previous. So again, it's kind of a cascading back up the chain type thing. And we are going to take input the loss versus the output of that layer. So imagine there's like a slash here. We're dividing this. This is a derivative, but we can't write that, so that's okay. We're not multiplying that. Yeah, so we'll have that, and then also similarly to this one, we want to be able to do it for a list. So again, our layers can freely convert between these. Speaking about converting between these, we are going to give all of our layers access to a function that does just that, does convert between them, and this will be really useful. So we'll have one that takes the list of double arrays and turns them into a linear vector. Cool, so we've got our dimensions from our input, and the length of our linear vector output is going to be all of those dimensions multiplied together. Cool, and so now let's just go through and linearize it. Cool, so here we've just set the value in our vector to be this value here, and we better increment I after we do that. Cool, and just going through every matrix in the list of matrices, every row of the matrix, and then every column of the matrix, and stringing it out into a big long one-dimensional thing. And so that we can convert between the output of our convolution layer, for example, which is a matrix, and turn that into input for our fully connected layer, which wants a one-dimensional vector input. Let's return our vector. Cool. And now I'm going to go ahead and write a function that does the reverse. Cool, so now we've got a function that does the reverse, so it turns a one-dimensional string into a matrix, and we specify the length of the list we want, the number of rows, and the number of columns. It could be wise to throw a little check in these functions to make sure that our dimensions are okay. I'm not going to do that because I'm trying to speed through this, and I've already done it all. But yeah, I recommend adding kind of errors to be thrown for your sanity when you're building this thing. So what else do we want in our layer function? So now we've kind of defined these functions that will work for either a list of matrices or a one-dimensional vector, backpropagation and output. One other thing that we want to be able to know is, given the size of this layer, we want to be able to get the expected output length from it. So that when we go to build the layer after that, we can check the last layer that we added to our network. Hey, what was your output size? And set that as the input size for the next layer. So we want get output length. So if there's a list of matrices, how long is that list length? Then we want to know how many rows are in that output. Same for columns. And then this one is elements, so that's basically like the total. So for example, if we have a one-dimensional output, get output elements will just be the length of that one-dimensional output. For something that outputs a list of matrices, get output elements will be equal to the length multiplied by the rows multiplied by the columns, but this is just a simpler method so that we don't have to do that multiplication every single time ourselves. So finally I'm just going to add some getters and setters for our next layer and previous layer. Just for these two. Cool, and that's our abstract layer class. And in the next video, I will be going ahead and implementing our first layer, which will be our fully connected layer.